trying to make sense of another formula, the forward interest rate formula. So the formula is as follows: r times t minus r times t divided by t minus t, where there are capital T's and small t's. The capital R and capital T is for the longer period, the interest rate and the period. The smaller t and smaller r are for shorter period interest rates. Now, how do I get the intuition of how this formula works? Let us look at the yield curve. Let's just say you have a yield curve with the following. It's a normal slope, normal yield curve, upward sloping normal yield curve. And then there is interest rate R, that's capital R, for the longer maturity T. And there is interest rate small r for the shorter maturity T. You know the two rates. You want to know what would be the interest rate between these maturities. You can do this by a technique called linear interpolation. In what you do, you know data, but you do not know the data in between. You try to estimate it through linear methods. And how do you estimate it through linear methods? Now let's just get some more intuition out of this. This is the curve, a very straight line curve. Let's just say this is the straight line curve. This is the longer maturity T. This is longer maturity R, and this is this is T. Then what is R times T? R times T would be this yellow box. Okay, then in the same curve you have something. Okay, just my bad, right? Okay, you have some shorter maturity with interest rate R and your time period T. Now, if we do RT minus RT, what would we get? We would get this area, and this area divided by this length, that is T minus T, would give us a good idea of this length, that is R, right? That is the estimated R. Very foolish, because this will only work at a very close points. Let's just say you have T and T very close, and then you have your spot yield curve with this and this. Then you see this area will not matter much, and therefore this linear interpolation fails to do interest rate interpolation for longer maturities and maturities with large differences in time period. So it's just an estimation. So you get the intuition behind it, and there is and it gives you the forward interest rate at T, that is your shorter maturity T, for the period T minus T. Okay, let's look at an example. So you have the following data. The spot yield curve, that is the government bonds maturity at T0, at T equals 0, is given as follows. For 1 year bond, it gives us 9.5 rate. For 2 year bond, it gives us 10.25. For 3 year bond, it gives us 11%. And for 4 year bond, it gives us 10.5. Now, if I want to extrapolate for first year, what will I do? I will take the interest rate at today, not today, at what is T1. T1 interest rate would be 9.5. T2, if I say T2 is a very close point to this, T2 interest rate is 10.25. Okay, for today, that's the spot yield. How do I estimate what would be the 1 year rate at T2? We would do this by multiplying T2, that is T2, you can see the capital letter T starts after small t, and capital letter R starts after the small letter r. Okay, this is how you do it. 10.25, that is your R, times 2, that is the corresponding yield at today, this is the T, minus this is R times T. This will remain same for every year of forward that we calculate, and similarly here and here, this is just T minus T, and you get 11, 11.75 and 10.83. Similarly, if I do for T2, so T2 will make our T2 is equals to second year, and you will have the small r2 will be given as 10.25, that is the current expected yield. If I'm not wrong, it's 10.25, yes. Then you can calculate for the next 1 year, that is the next 1 year. So you can see T1 minus T2 gives us 1, this gives us 1. So it is the forward interest rate at T2 expected for 1 year, and the same for this would be T2 to T4. A very short video just to get this intuition right, but the formula fails. It actually fails to capture the true essence. The better method is to go for IRRs. What is the IRR method? I'll just quickly tell you about it. So the basic idea behind this is you should not have a deviation in valuation. So let us say you have a bond of 5 years, 5-year bond, and you also have a 2-year bond. So if you invest in a 5-year bond and you invest in a 2-year bond and then reinvest in a 3-year bond, both should give same yield. That is the idea. You cannot take, otherwise there would be arbitrage. People would, if the 5-year bond was giving better yield and this combination would not, then people would sell this combination and buy a 5-year bond. So using the arbitrage pricing, we can arrive at something equivalent. So a 5-year bond will give same yield as a 2-year bond at T0 plus 3-year bond at T2. Alright, and this can be then extrapolated by using the IRR method. That is when you would get the value of T5 bond, you could get the value of T2 bond, but you don't know the value of a T3 bond. So you would just get the T3 bond value, and then you can extrapolate the IRR or find out the IRR for the T3 bond, and that's how you get the forward rate at T2 for 3 years. This is the basic idea, but that IRR method is not linear method. It's a non-linear method. You go for solving for the accurate rate, which could be on the curve as well and not on a line, because whenever you are assuming it is linear, it would assume that everything lies on a straight line, and that is the fallacy between this formula, I guess. And that is all. This is me signing off.